Okay, so one of the first mechanisms that they teach you in organic chemistry are the ones between an acid and a base. And one of the most commonly used bases is sodium hydroxide. So you have like NaOH. And I'm going to put the lone pair electrons on here because I'm going to be using them later. So let's focus on these lone pair of electrons here. So this sodium has a positive charge, this hydroxide has a negative charge. So I'm going to highlight them yellow so that you can tell that they're charged. Okay, so then let's say that you react this with like, okay, like what's one of the bases that you most commonly use from uh, general chemistry? That's hydrochloric acid. This is a single-headed reaction because the equilibrium lies all the way to the right. Okay, so what we're going to show here is the flow of electrons. So these electrons are going to attack this hydrogen, and then this bond is going to break and the electrons are going to go to the chlorine. So like in organic chemistry, what you'll see a lot is that basically like all the mechanisms, the ionic mechanisms, they're going to be like where electrons are, and then you're going to draw some wiggly arrow or squiggly arrow towards where either there's a positive charge or a partial positive charge. So this is like, you know, if you wanted to summarize organic chemistry, that's what you'd summarize it into. Electrons going towards positive charges. And that's supposed to be a positive charge here. There you go. Okay, so towards partial positive or positive charges. And this could also be like partial negative, but usually it's a pair of electrons going there. Okay, so anyways, back to the mechanism. So right here we have sodium hydroxide reacting with hydrochloric acid. Well, I'm going to label these ones blue so that you can see where they're going. So the tail of the arrow always comes from where the electrons are. So like that's why I put the tail of the arrow over here. And they always go towards where right here this hydrogen is partial positive charge, is attached to a chlorine that's electronegative, so it's partial negatively charged. So electron going from a negative hydroxide towards a partial positive hydrogen. So then now what's going to happen after you make a bond, you have to break a bond. So these two electrons here on the hydrogen chlorine bond are going to break and they're going to go towards the chlorine. Okay, so after this happens, well, what are my products for the reaction? So I'm going to first put so the chlorine is now going to be by itself here. And it looks like these electrons now went towards the chlorine. So I'm going to put those electrons as, bam, right here. That's where they went. Now they're next to the chlorine. And obviously, like this chlorine has like lone pairs over here, but we're just not showing it for this reaction mechanism. And now since it has an extra pair of electrons, now it has, overall, it has a formal charge of -1. So -1. So we're going to put a negative charge on that chlorine. And we're just going to put the counter cation next to it. So we got Na plus, and in addition to that, well, what did we make on the left side? We took a hydroxide molecule and then we combined it with a hydrogen. So now we have a water molecule. So I'm going to put this hydrogen facing up so that you can see that this hydrogen came from the HCl. So I'm going to put it up there, and then I'm going to put where those electrons came from. These electrons came from the oxygen, which already had like 2 lone pairs, not blue. So these ones are right here. And that's neutral, so that's a water molecule. So overall, what happened was that this hydroxide, not the arrow didn't go anywhere. It made a bond with this hydrogen over here. So then this is what you're ending up with over here. So this is like your new bond that was formed between the oxygen and the hydrogen. And then after that reaction occurred, then you had your chlorine go by itself. So now it's got those 2 electrons, and that's how you end up with NaCl. So this is like an arrow pushing mechanism, and you'll see a lot of these in organic chemistry. They just get a little bit fancier, but overall this is called proton transfer step. Proton transfer. Cool, that's it.